Hey everyone, and welcome to another video. In this one, we're going to be showing you how to create a multisig wallet or a multisig safe with multiple owners, meaning that not only one owner signs the transaction, but maybe you require 2 or 3 or multiple ones. And these features can be quite helpful when you design a group wallet or even a wallet with two-factor authentication. So without further ado, let's get started. But before I dive into this tutorial, I want to make sure that you already are familiar with how to send your first user op video. If you haven't done so already, you can go through this guide, send your first transaction, and then you should be good to go for this multisig feature. So the first thing, we'll actually need a second owner to our safe. So we're going to be designing a safe that have 2 owners, and we'll make them both required to sign each transaction on that safe. So you'll get not only one owner or one key, you'll get 2 keys. And this is exactly what I did. I went into my ENV and I pasted in 2 OAs as the owner of my safe, the first one and the second one. Now, in my safe initialization, I need to pass in not only one single owner, but also the second one. So I'll get in the owner public address here, which is 1 from my ENV, and we'll get the second one as well, and then we'll paste it in both owners during the initialization function of my safe. Now, if I want to customize the threshold, I can pass in the threshold in the overrides, and I'll have it as 2. So that way we have a safe, a 2x2 safe, meaning I require both owners signing each transaction. Now, before I run all this code of minting the NFT and sending you the user op, let's actually calculate the address of the safe and see what we're gonna get. So I just calculated the address, no on-chain operation happens, and you can actually make it so that whenever you design your wallet, you have an address that can be funded without requiring the user to make a transaction. And it's very similar to how EOAs are designed today. So that way you have an address here, we could fund it with some ETH. But in this example, we're actually going to be using a paymaster, so we don't even need to fund it to deploy the account. So now let me uncomment again. And then during this code, if you remember from the previous video, we're actually minting 2 NFTs. So transaction 1, transaction 2. And then we're doing create user operation here with both transactions. On the first user op, it's always deploying the account, as you know. And this is the paymaster step right here. It's sponsoring the gas using a sponsor user operation. And then here, the step where we actually need to sign with both private keys. So it's very similar to the previous step. We're going to do private key 2, and we'll copy this. It's going to be exactly the same. So this is private key 2, this is private key 1 from my ENV, and then I'll pass it in sign user operation. I'll do private key 1, private key 2. That's it. Now we can run this code, and we get our first error. So let's see the error. Init code failed or out of gas. So AA13 init code failed out of gas. If you don't know what this means, you can just go Google this error and then see what we're gonna get. So we're gonna go to the docs and then Google the error. The init code failed to create the account or ran out of gas. So it might be two things. It either ran out of gas, so we have to check the pre-verification gas if it's 2 liter, or the init code or the factory contract is incorrect. So it's something in our setup that is not correct. So let's take a look if we've done everything correct. So during the setup, we have public owner 1, and you can see the error here. I actually included the owner twice. So it's actually public address 2. So that was the error. So let's try to run this code again. If you notice, we actually got a different address here than the previous one that was miscalculated. And then we're getting the user op. Here's the user op hash. Maybe my console is not correct. It's probably that was my console. Let's make it correct next time. And here we go. We got the transaction hash. Let's go on a block explorer and take a look. So we can see here the account minted 2 NFTs, and actually it's a deployment of the account. So this is our account right here. If you remember, the same as this one. And then if we go to this account, we're gonna see it's a safe. Now let's check the owners of the safe. So let's see the owners of the safe. Can we read as proxy on doc scout? Yes, let's do this. Read as proxy. We cannot. So let's try Etherscan. Here we go. So on Etherscan, can we read as proxy? No, but I know we can do this. Is this a proxy? Verify. Now we can go back, read as proxy. Here we go. Now we can read the functions, get owner, query, and we got indeed 2 owners of the safe, and these are the 2 owners that we got into our safe. So any transaction that we make requires the signature of these two owners because the threshold is actually two out of 2. And so let's try to actually remove one of the owners, right? So how can you remove it? We'll go into the SAFE SDK reference right here, and there's a function called remove owner meta transaction, and we'll just remove it. So let's see how we can do it. So instead of minting all the NFT, we can remove all the code related to the NFT, and then we'll do constant transaction one smart account dot create remove owner meta transaction. It takes the node RPC, which we have right here, so we have to put it up in the right order, and it takes the owner to delete. So let's say we want to delete the owner number 2, and that's pretty much it. And then the thresholds, but let's see if it's going to be 1, then we don't have to remove it. So that way, do we have to? Expected 3 arguments. Yeah, so we need to add a new threshold, and the threshold is going to naturally be 1 because it's going to be a safe 1 out of 1. Now it's transaction 1, and transaction, it's a promise, so we have to do await, and we're good to go. So now let's execute the transaction and see if we are able to remove the second owner of this safe. So here's the UserOp hash. So if this is a UserOp hash, but the transaction hash is quite different. You can still track the UserOp hash on Block Scout, which is why I like Block Scout, by the way. And the transaction hash is the official E-type transaction hash. And now it's ready. You can see that we already did execute the transaction, and it removed the owner. So let's see if it actually happened on chain. So let's query this function again, get owners, and indeed we remove the second owner of the safe. Now let's try another one. Let's try create swap owner. Create swap owner, essentially you can replace one owner with another one. Let's try this out. So it's similar to remove owner. We can just do create swap owner meta transaction, and swap owner takes the node RPC URL, takes a new owner. So if you remember, our current owner is owner number 1. So let's do owner number 2 this time as the main safe. And then it takes the old owner number 1, and that's it. It doesn't require any threshold because we're just swapping owners. And transaction, it's actually a meta transaction, so it returns an array, the swap owner meta transaction, so we don't need to include the array right here. So let's try this again. So if you remember, our previous owner is 0x26. So if we execute this transaction, we should have it a different owner. All right, transaction is executed on chain. Let's see. And then we have a new owner, 0xAF. That's our new owner to the safe. Cool. Now the last function we could demonstrate is create add owner. So we can actually add an owner to a safe, even if it's deployed from before. The one thing we actually didn't, so let's try to add an owner to a safe. Now let's see, create add owner threshold meta transactions. And instead of having, so we know that our owner at the moment is 0xAF, which is owner number 2. Now let's add owner number 1 again to the safe. So owner number 1, so new owner, and then let's add the threshold as let's add it as threshold as 2, and then let's execute this transaction again. We have an error invalid UserOp signature. That means that we're not signing with the right owners. So we actually signed with both owners, which we don't need. So the original owner of the safe is 0xA, which is private key number 2. So we only need the signature of second owner. So let's try this again. All right, seems like it's going. Here's the UserOp hash. Let's try it out. So still not being found on Block Scout. And here you go. It was minted. So let's try to refresh. UserOp executed. And let's query again the owners. Now we have both owners again to the safe. So the last thing I want to mention is that during our initialization function, we always passed our initial owners right here, and we never changed them during the modification because we always get the same address, even if we remove the owner and added the owner. But a good practice is that if the safe is already deployed, then you can pass in the safe address like the following. So you can do smart account equal new safe account, and then you can pass in the account address that of the safe that we already calculated and deployed before. So you can only use this code on deployment, and then after that, after each transaction, you can use the instant of the safe like the following. And that's it. That's how you create multi-sig wallets using Safe.